Today we're going to start with 7.1a. We are going to be talking about reducing, multiplying, dividing rational expressions, and also finding what the domain is. The first thing when we're doing this is that you want to factor the expression. Make sure you're doing the numerator and the denominator, the top and the bottom, and then you'll simplify or cancel out any like terms that you are able to. So on our first example, a lot of you like to use diamond method in order to factor this. So if you make your diamond, remember that this -3 right here, that is your multiplication number. And this number in the middle, -2, that is your adding or subtracting number. Okay? So -3 is my multiplication and -2 is my adding number. So if we list all the numbers that multiply to be 3, we have 1 and 3, and that's it. So we put 1 and 3 here, and since 2 is negative, the larger number has to be negative. And we double check. Is 1 times -3 -3? Yes. Is 1 plus -3 -2? Yes. So we know we have the correct numbers. So my numerator factors to be x plus 1 times x minus 3. Over, and then we have to do the same thing to our denominator. So again, -6 is my multiplication number, and if there's no number in front here, that's a -1, is my adding number. The numbers that multiply to be 6 are 1 and 6 and 2 and 3. The only numbers that work there would be 2 and 3. So, but in order to add them to make a -1, we have to make the 3 negative. So again, double check. 2 and -3 add to be -1, and they multiply to be -6. When we factor, we get x plus 2 and x minus 3. At this point, you are going to reduce. So if you notice, x minus 3 and x minus 3, those are the same, so we can cancel these out. X plus 1 and x plus 2 are not the same, so that means my answer is x plus 1 over x plus 2. Some people want to cancel out the x's, but anytime you have an x and it's adding something or subtracting something, unless they are exactly the same, you cannot cancel them out. All right, moving on to example 2 now. If you notice on the top on this, you have a GCF. So we need to take out the GCF first. You look at your numbers as well as your letters. So in the numbers, I can take out a 2, and with the letters, I can take out an x. When I factor that 2x out, I'm left with x plus 5. And always check if you can factor further, and this won't factor further. So now we go to our denominator. So in the denominator, 3 is not a GCF, so we have to use our over, under, bottoms up method. So when I do that, I go over by 3 to my last number, and I make my new equation as x squared plus 16x plus, and 3 times 5 is 15. Then you can do your diamond. We're multiplying to be 15 and adding to be 16. The only numbers that will work there are 15 and 1. When I write out my factors there, I have x plus 15 and x plus 1. But since I went over by 3 at the beginning, I have to remember to go under by 3 and reduce. So when I do that, I end up getting x plus 5. And since 1 over 3 doesn't reduce, we bring our bottoms up and get 3x plus 1. So my denominator is x plus 5 and 3x plus 1. And if you notice, my x plus 5s, these are the same, so I can cancel out 1 for 1 on the top and the bottom, and I'm left with 2x over 3x plus 1. And that is my answer. All right, moving on to example 3. So, on the top, it cannot be factored. It is x minus 4. On the bottom, so we can go ahead and just write x minus 4. On the bottom, though, if you notice, this is a difference of cubes. So remember, when we're working with cubes, we need to write both of the terms as cubes. So we already have x cubed, and 64, if you look over on the wall on the pink sheet, remember we have all the cubes listed, and 4 cubed is 64. So now when you factor this, hopefully you remember, but you make 2 parentheses. One is short and one is longer. In your first parenthesis, all you're doing is rewriting what your cubes were, but without the cubes. So I'm just taking off these cubes right here, and I'm writing x minus 4. But you can only write that if these are written as cubes. Then your first term here is the first term squared. So x squared is what goes here. Your last term, remember, is your last term squared. So negative 4 squared is positive 16. And then your middle term is those multiplied together. So x times negative 4 is negative 4x, but it's the opposite. So it's going to be positive 4x. And again, if you wanted to, on the wall, there is an orange poster that gives you the formulas for these cubes. And remember too, there should only be one negative in all this factors. And so that's the only negative that's in the problem. So either you're going to have a negative in that spot or a negative in that spot when you're dealing with cubes. So at this point, hopefully you see that these x minus 4s canceled. Remember, if nothing is left on the top, there really is a 1, and then it's 1 over x squared plus 4x plus 16. And this is not factorable. So this is your answer. Okay, moving on. Example 4. If you notice here, there are 4 terms. When you have 4 terms, you're going to use grouping. So we are grouping our first 2 terms and our last 2 terms. So in the first term, we take out the GCF. So our GCF is x squared, and we're left with x minus 5. In this group, I'm going to take out a negative 3 because I want my minus to be in the middle like it is here. So my GCF would be negative 3, and when I divide each of these by negative 3, I'm left with a positive x and a negative 5. The whole purpose is that these will match. So now my GCF is taking out x minus 5. So I end up with x minus 5, and that's if I divided each of these by x minus 5, then I'm left with x squared minus 3. And that cannot be factored any further. So my numerator has been factored. So now we go to our denominator. We're looking for a number that multiplies to be 15 and adds to be negative 8. If we list all the numbers that multiply to be 15, you have 1 and 15 and 3 and 5. 3 and 5 are the only ones that can make 8. And in order for them to add to make a negative and multiply to be a positive, both of them need to be negatives. So negative 3 plus negative 5 is negative 8. Negative 3 times negative 5 is positive 15. So we have x minus 3 and x minus 5. Hopefully you notice the x minus 5's match. Do the x squared minus 3 and an x minus 3, are those the same? Hopefully you're saying no. This has an x squared. So it is totally different than a plain x. So since that can't reduce, my final answer here is x squared minus 3 over x minus 3. Okay, moving on. On example 5 now. X minus 1 cannot be factored. So my numerator stays as x minus y. My denominator, though, has a GCF of 8. But if you notice here, see how here the y is positive and on the top y is negative. Here x is actually negative and here x is positive. So if I take out a negative 8 and I divide each of these by negative 8, I end up getting a negative y, and here 2 negatives make a positive, and a positive x. And I can rewrite that so it looks the same. So I still have a negative 8 in front, and I can write this as x in front is positive minus y in the back is negative. And then I can cancel these out, and I end up with 1 over negative 8 as my answer. So just know if they don't look exactly the same, if you can take out a negative, then maybe they'll end up becoming the same. So there's a few problems like that. All right, example 6. 2 plus x squared means that you actually have 2 plus x 2 times. I'm sure you knew that. And then we can do our diamond on the bottom, what multiplies to be 8 and what adds to be 6. The numbers that multiply to be 8 are 1 and 8 and 2 and 4. So 2 and 4 add to be 6 and multiply to be 8. So we have x plus 2 and x plus 4. Now if you notice on this, even though they don't look exactly the same, that both the x's are positive and the 2's are positive. They're just written in a different way. So we can go ahead and cancel out 1 for 1, but only 1 for 1. So my answer now on the top, and you can go ahead and write it with x first if you want to. It is x plus 2 over x plus 4. So that is my answer. All right, moving on to multiplication now. You will need to factor if needed, and then you will cross cancel and simplify. Okay, so anything on the top can reduce with anything on the bottom. So you can cross cancel diagonally or on top. Okay, it is up to you. Now my suggestion is to combine like terms first and then reduce so you don't mess up. Sorry for all of the talking in the background. Okay, so I'm going to keep 5 on top right now. I have x cubed on top, and then this is y to the first and y to the third, which will end up making y to the fourth. On the bottom, I have 15, and notice I have x squared and x squared, which will make x to the fourth, and then I just have 1y. Now I would go ahead and reduce, and this will help you so that you don't mess things up. So 5 and 15, 5 goes into 15 3 times. So my denominator down here, I have a 3 right now. With x to the third on top and x to the fourth, remember if it's dividing, you can subtract exponents, and then it stays on the side of the larger exponent. So that means if I subtract 4 minus 3 is 1, so I have 1 left over, but it's on the bottom because my larger one is on the bottom. And I'm not going to keep doing this, but what this actually means is you have x times x times x on the top and x times x times x times x on the bottom. And you cancel out 1 for 1 like that and see how I just have 1 left on the bottom. Okay? Here, if this doesn't have 1, it's a 1. So 4 minus 1 is 3, but that means since 4 is bigger, you have 3 y's left on the top. And that is your final answer. Moving on to example 2. I can factor 3x minus 12 by taking out the GCF. So I take out a 3, and then I have x minus 4. The denominator there is still x plus 5. Times, I still have x plus 6 on the top over here, and on the bottom here I can take out a 2, and then that is x minus 4. Again, you can reduce anything on the top with anything on the bottom. So the x minus 4's match here, and nothing else can reduce. So my answer is 3 times x plus 6 over, and then 2. We always write the multiplication number in front. So if you have just a plain number by itself, bring it out to the front, and then I have x plus 5. And so that is my final answer there. All right. I am going to stop here and start the second part so that I can also upload this to the website. So